Hello everyone, this is Abhishek Mohanty and welcome to lecture number 9 of the chapter Electric Charge and Field. In the previous lecture, we had discussed about electric field lines and their properties. Today, in this class, we will discuss about a new topic and the topic name is electric dipole. So, let's get started. So students, what is the meaning of electric dipole? So look at the name of the term electric dipole. Di means what? Di means two. Di means two, and pole refers to the polarity. Pole refers to the polarity of charge. We know that we have two types of charges, positive and negative charge. So in an electric dipole, we have two charges. One is positive, the other one is negative. And there should be some distance between the two charges. So how to write the definition of electric dipole? The definition is two equal and opposite charges, two equal and opposite charges separated by a small distance, constitutes an electric dipole. Means in an electric dipole we have two equal and opposite charges. Equal means the magnitude of the two charges should be same, and opposite means their polarity should be different. Means we have to take two unlike charges, positive and negative charge, but their magnitudes should be same. For example, if you take an electron and a proton, and there is some distance between the two charged particles, then this one will constitute an electric dipole, because we know that electron is negatively charged, proton is positively charged, but the magnitudes of their charges are same. The magnitude of the charges of proton and electron are same, and the value is 1.6 into 10 to the power minus 19 coulomb. Electron is negative and proton is positive. So this is the example of an electric dipole. So in general, we can write in an electric dipole we have two charges, minus q and plus q. We have two charges, minus q and plus q, negative and positive charge, and there must be some distance between the two charges, and this distance is known as the dipole length, and it is represented by 2a. The dipole length is represented by 2a. 2a is the dipole length, or you can say that this is the separation between the two charges. So if this point O is the midpoint of the line joining the two charges, then point O is known as the center of the dipole. Point O is known as the center of the dipole. Is that clear? So remember that two equal and opposite charges separated by a small distance constitutes an electric dipole. So minus q plus q are the two charges having equal magnitude and opposite polarity, and the separation between them is 2a. 2a is known as the dipole length. Now the strength of this dipole, the strength of this electric dipole is measured by a quantity. The name of the quantity is dipole moment. Like to measure the strength of electric field, we use a quantity electric field intensity. Similarly, to measure the strength of dipole, whether the dipole is strong or weak, to measure the strength of the dipole, we use a term known as dipole moment. and this dipole moment is denoted by the letter P. Dipole moment is denoted by the letter P, and this dipole moment is a vector quantity. Dipole moment is a vector quantity. Since dipole moment is a vector quantity, it must have magnitude and direction. So now we will discuss about what is the magnitude and what is the direction of dipole moment. So the magnitude of dipole moment, its magnitude is equal to the product of magnitude of either charge and the separation between them, The magnitude of the dipole moment is equal to the product of magnitude of either charge and the separation between them. For example, suppose I have an electric dipole having charges -3 microcoulomb and +3 microcoulomb. At point A, I have a charge -3 microcoulomb, and at the point B, I have a charge +3 microcoulomb. And the separation between the two charges is 3 millimeter. Let us assume that the distance between the two charges is 3 millimeter. Then how to find the magnitude of the dipole moment of this dipole? The magnitude of dipole moment P is equal to the product of magnitude of either charge. So we have two charges and they have the same magnitude. Magnitude means the positive value. So Q into the separation between the two charges, Q into 2A, this product, the magnitude of either charge and the separation between the two charges, or the dipole length, Q into 2A is the magnitude of the dipole moment. So in place of Q, I can write 3 microcoulomb, because magnitude means you have to take the positive value only, into 2A. 2A is the dipole length, which is 3 millimeter. Students, I have seen in many cases many students do one simple silly mistake. What is the mistake? They think that if the distance between the two charges is 3 millimeter, then 2A will be 6 millimeter. They think that the distance is A, so if we have to multiply 2A, then we have to write 6 millimeter there. But this is wrong. The dipole length, or the separation between the two charges, is itself 2A. It is not A. So 2A is 3 millimeter. If the dipole length is 3 millimeter, it means 2A is 3 millimeter. So there is no need to multiply another 2 here. Is that clear? And again we have to convert this unit to SI system. So 3 microcoulomb, micro means 10 to the power -6. So 3 microcoulomb will be 3 into 10 to the power -6 coulomb, and 3 millimeter means 3 into 10 to the power -3 meter. So 3 into 3 will be 9, into 10 to the power -6 into 10 to the power -3 will be 10 to the power -9, and the unit will be coulomb into meter. So the unit, the SI unit of electric dipole moment is coulomb into meter, because it is the product of charge and separation between the charges, charge and distance. So the SI unit is coulomb into meter. And what is the dimension? The dimension of dipole moment will be how much? We are multiplying charge with distance. So the dimension of electric charge is A1 into T1, and the distance has dimension L1. So the dimension of dipole moment will be how much? M0, L1, T1, A1. Is that clear? So this is the dimension of dipole moment. So in this way you can find the magnitude of dipole moment. But this dipole moment also has a direction. because it is a vector quantity. So what is the direction of dipole moment? Dipole moment is directed from negative to positive charge, from negative to the positive charge. Dipole moment is directed from negative to the positive charge. So look at the diagram here. In this diagram, at A we have a charge of -3 microcoulomb, negative charge, and at the point B we have a positive charge. So here the dipole moment is directed from negative to the positive charge, from negative to the positive charge. But electric field intensity is directed from positive to negative charge. This is the difference between the direction of electric field intensity and the direction of electric dipole moment. Dipole moment is directed from negative to positive charge, but electric field intensity is directed from positive to the negative charge. So this is all about dipole moment, its magnitude and the direction. Now we will come across a term known as ideal dipole. Ideal dipole. So what is the meaning of ideal dipole? Ideal dipole means, we know that in a dipole we have two charges and there must be some distance between the two charges. In ideal dipole what happens? The magnitude of charge is very large. Magnitude of the charge is very large, and the dipole length means 2a, or the separation between the two charges is very small, means q tends to infinite and 2a tends to 0. 2a tends to 0 means what? The dipole length is very small but not equal to 0. If you make 2a equal to 0, then the dipole moment will also become 0. So the dipole length should not be 0, but it should be very small. In case of ideal dipole, the distance between the two charges should be very small and the magnitude of the charges should be very large. That's why I have written q tends to infinite, means the magnitude of the charge in that dipole is very large and the separation between the two charges is very small. That is known as an electric dipole. So this is all about electric dipole, its dipole moment and the direction. Now we'll go to find an expression for the electric field produced by a dipole. So let's discuss about that. So students, we already know the formula to calculate the electric field intensity due to a point charge. If a point charge is placed in vacuum, then the electric field intensity at a distance r from it is given by E equal to 1 by 4 pi epsilon naught q by r square. But in case of a dipole, we have two charges, minus q and plus q. So whenever we want to find the electric field intensity due to a dipole, we have to consider the electric fields produced by both the charges. So today we will derive an expression for the electric field due to a dipole, and the derivation will be under three headings. The first one is electric field due to a dipole at an axial point, at an equatorial point, and at an arbitrary point. Electric field due to a dipole at axial point, at equatorial point and at an arbitrary point. So what is the meaning of axial point? Suppose I have a dipole consisting of two charges, minus q and plus q. Is that clear? So this is the line which joins the two charges. If I extend the line on both sides, then that line will be known as the axis of the dipole. If you extend the line on both sides, then this line is known as the axis of the dipole. And any point on the axis is known as the axial point. So let me choose a point P here. Let me choose a point P at this point, and we want to find the expression for electric field at this point. The separation between the two charges or the dipole length is 2a. The separation between the two charges or the dipole length is 2a, and this one is the center of the dipole. Point O is the center of the dipole, and P is an axial point. So we have to find the electric field at the axial point. This axial point is also known as the end-on position. Axial point is also known as the end-on position. So let us find the expression for the electric field intensity due to this dipole at an axial point. Suppose the distance of point P from the center O is r. The distance of the point P from the center O is r, and the dipole length is 2a. Since O is the midpoint, it means, suppose this is point A and this is point B, so AO, the distance is A, BO, the distance is A, because O is the midpoint of the dipole, and the point P is at a distance r from the center O of the dipole. So in order to find the electric field at this point P, you have to look at the dipole system. In the dipole we have two charges, a positive charge and a negative charge, and you know that every charge produces its own electric field. So at point P we will get electric field due to the plus Q charge and electric field due to the minus Q charge. So when we have multiple electric fields, when we have two or more than two electric fields, then to find the resultant electric field or to find the net electric field, you have to add all the electric fields vectorially, because electric field is a vector quantity. Is that clear? So at point P, what will be the expression for electric field intensity due to the positive charge? Let us first write the expression for the electric field intensity at the point P due to the positive charge plus Q. So E plus Q. We know that the formula for the electric field due to a point charge is 1 by 4 pi epsilon naught into magnitude of charge divided by distance square. So here the distance of the charge plus Q from the point P is AP. So I can write AP square. Is that clear? And this electric field has a direction. We had already discussed that the electric field at a point due to a positive charge is directed away from the charge. So E plus Q means electric field due to this positive charge will be directed away from it, means towards right. And we had discussed that the dipole moment is directed from negative to the positive charge. The dipole moment is directed from negative to the positive charge, means P vector is directed from left to right, from B to A, means towards right. So the unit vector along P cap can be written as sorry, the unit vector along P vector can be written as P cap. So P cap is also directed towards right. So you can see that the direction of E plus Q, the direction of E plus Q is along P cap. So you can write P cap here. The direction of E plus Q is along P cap. Is that clear? So 1 by 4 pi epsilon naught Q divided by AP. What is the value of AP? So OP, the distance OP is R and the distance OA is A. OP is small r and OA is small a. So AP will be R minus A. So in place of AP I can write R minus A. So E plus Q is equal to 1 by 4 pi epsilon naught Q by R minus A whole square into P cap. Is that clear? Similarly, E minus Q means the electric field at the point P due to the negative charge. Again, the expression is 1 by 4 pi epsilon naught into magnitude of the charge. So while writing the magnitude of electric field, don't put the sign of the charge particle. Always put the magnitude of the charge. So E minus Q vector will be 1 by 4 pi epsilon naught. The magnitude of the negative charge is Q divided by BP square. And we know that for a negative charge, the electric field is directed towards it. The electric field is directed towards the negative charge. So this one is for E plus Q and this one is for E minus Q. And you can see that this E minus Q is directed opposite to the dipole moment. Dipole moment is towards right, but E minus Q is towards left. So I can write minus P cap here. Means the electric field due to the negative charge is opposite to the dipole moment direction. So 1 by 4 pi epsilon naught Q divided by, what is the value of BP? OP is R and BO is A. So BP will be R plus A. So write R plus A square into minus P cap. So these are the values of E plus Q and E minus Q. So we have two electric fields at point P. So the resultant electric field or the net electric field, resultant electric field or the net electric field will be E axial. And here you have to add these two electric fields vectorially. So E axial will be E plus Q vector plus E minus Q vector. So E plus Q is this much, 1 by 4 pi epsilon naught Q by R minus A whole square into P cap, plus E minus Q vector will be 1 by 4 pi epsilon naught Q by R plus A whole square into minus P cap. Okay, and this minus symbol you can take to this side. Okay, so now you can take Q by 4 pi epsilon naught common. Inside the bracket you will have 1 by R minus A whole square minus 1 by R plus A whole square whole into P cap. Is that clear? So now let us simplify this expression. So E axial is equal to Q by 4 pi epsilon naught. Now you can take LCM. The LCM will be R minus A whole square into R plus A whole square, R minus A whole square into R plus A whole square, and here you will get R plus A whole square minus R minus A whole square whole into P cap. Is that clear? So we'll get q by 4 pi epsilon naught a plus b whole square minus a minus b whole square is 4ab. So here we have r plus a whole square minus r minus a whole square. So this will be 4ra divided by, this one will be r minus a into r plus a whole square into p cap. So q by 4 pi epsilon naught. This 4ra can be written as 2a into 2r. 4ra can be written as 2a into 2r divided by, this one will be r square minus a square, a minus b into a plus b means a square minus b square. So we'll have r square minus a square whole square into p cap. And this q into 2a is the dipole moment P. So I can write 1 by 4 pi epsilon naught q into 2a will be P. Then we have 2r divided by r square minus a square whole square into p cap. So E axial is how much? 1 by 4 pi epsilon naught p into 2r divided by r square minus a square whole square into p cap. So you can say that the electric field at the axial point is directed along the dipole moment, because in the direction part we have p cap. So there is a special case. And what is the special case? For a short dipole, the special case is for a short dipole. Short dipole means what? The separation between the two charges or the dipole length is very small. It is very small compared to the distance r. Means 2a is very small than r. For a short dipole, 2a is very small than r. Means look at this denominator here. We have r square minus a square. If the dipole length is very small than r, then definitely a square is very small than r square, or r square is very large compared to a square. Means r square is very large than a square. So in that case, r square minus a square is approximately equal to r square, because when you subtract a very small quantity from a very large quantity, the result will be approximately equal to the large quantity. So for a short dipole, what will be the expression for E axial? E axial is equal to 1 by 4 pi epsilon naught p into 2r divided by, in place of this value r square minus a square, you can write r square. So we will have r square, and here we have another square. So 1 by 4 pi epsilon naught p into 2r divided by r to the power 4 into p cap. So if you cancel it, you will get r to the power 3 here. So E axial for a short dipole is 1 by 4 pi epsilon naught 2 into p divided by rq into p cap. So this is the final expression for the electric field at the axial point of an or of a short electric dipole. So now we will go to derive the expression for electric field due to a dipole at the equatorial point. So the new derivation will be the electric field due to a dipole at the equatorial point, or it is also known as the broadside on position. So what is the meaning of equatorial point? Suppose we have an electric dipole minus q and plus q. The dipole consists of the two charges. At A we have a charge plus q, and at B we have a charge minus q, and this point O is the center of the dipole. So we have to understand what is the meaning of equatorial point. Equatorial point means any point lying on the equatorial line. Any point lying on the equatorial line of the dipole. So what is the meaning of equatorial line? Draw a perpendicular bisector. Draw a perpendicular bisector to the dipole axis. This is the axis of the dipole. If I draw a perpendicular bisector, means a line which is perpendicular to the dipole and it bisects the dipole, means if the dipole length is 2a, then OA will be A, OB will be A. This line is known as the equatorial line, and any point on the line is known as equatorial point. Suppose I will consider a point P. I will consider a point P here. This point P is known as equatorial point. You can choose a point here, at any point on the line. Every point on the equatorial line is known as the equatorial point. Is that clear? So now we have to calculate the electric field intensity due to this dipole at the equatorial point. And suppose the distance of the point P from the center O of the dipole is R. So if I join P with A and P with B, then you'll see that length of AP and BP will be same. According to Pythagoras theorem, this one is A, this one is A, so AP will be R square plus A square square root. Similarly, BP will be the same, R square plus A square square root. Means the point P is equidistant from both the charges of the dipole. Now we have to find the electric field intensity at the point P. Okay, so again we have two charges, plus Q and minus Q, so we'll get two electric fields at the point P, and then we have to take the vector sum of the two electric fields. So first I'll write the expression for E plus Q. E plus Q means the electric field intensity at the point P due to this positive charge plus Q. So what will be the value? E plus Q will be 1 by 4 pi epsilon naught magnitude of charge divided by AP square, the distance square. And what is the distance? The distance is square root of R square plus A square. So distance square will be R square plus A square. Is that clear? And we know that for a positive charge, the electric field is directed away from the charge. Means E plus Q will be directed along AP, away from the positive charge, along AP. Is that clear? Now write the expression for the electric field due to the negative charge. E minus Q. Again it is 1 by 4 pi epsilon naught into magnitude of charge divided by BP square. And again the value of BP is same as value of AP. So BP square means R square plus A square. So write R square plus A square here. And since this is a negative charge, the electric field due to the negative charge will be directed toward the charge. So this is the direction of E minus Q. So E minus Q is along PB. E plus Q is along AP, and E minus Q will be directed along PB. So write along PB. Is that clear? So we have two electric fields at the point P. And here you can see that the magnitude of E plus Q and the magnitude of E minus Q are equal. The magnitude of E plus Q is same as the magnitude of E minus Q. And let us say that this magnitude is X. Means X is equal to how much? 1 by 4 pi epsilon naught Q by R square plus A square. So we have to find the resultant electric field. And how to find it? We have to add the two electric fields vectorially. So suppose imagine that this angle is theta and this angle is theta. Because AP and BP, they have equal length, so their angles, these two angles, the opposite angles will also be same, theta and theta. If these two angles are theta and theta, then this angle will be theta plus theta, means 2 theta. So we got that the angle between the two electric fields, the angle between E plus Q and E minus Q is 2 theta. So we know from the class 11, we know that the magnitude of resultant is equal to A square plus B square plus 2AB cos theta square root. If we have two vectors A and B, and if theta is the angle between them, then the magnitude of the resultant vector is given by this formula, A square plus B square plus 2AB cos theta, where theta is the angle between the two vectors. So here in place of A we have E plus Q, in place of B we have E minus Q, and the angle is 2 theta. So the resultant electric field, or E equatorial, the magnitude of the resultant electric field E equatorial will be how much? Square root of E plus Q square plus E minus Q square, but E plus Q and E minus Q both are the same value, that is x. So I can write x square plus x square plus 2AB, means E plus Q, E minus Q, both are x, x into cos angle between the two vectors, which is 2 theta here. Is that clear? The angle is 2 theta. So x square plus x square will be 2x square, plus this one will be 2x square into cos 2 theta square root. So 2x square taking common, you will get 1 plus cos 2 theta square root. This is equal to 2x square into 1 plus cos 2 theta will be 2 cos square theta. 1 plus cos 2 theta will be 2 cos square theta, and here we have a square root. So if you remove the square root, then you will get 2x cos theta. You will get 2x cos theta. So the magnitude of E equatorial is found to be 2x cos theta. So 2 into x, what is x? X is this much, 1 by 4 pi epsilon naught q by r square plus a square. And what is cos theta? Look at the triangle BOP or look at the triangle AOP. Cos theta will be B by H. B by H. B is A and H is r square plus a square square root or power half. Square root means power half. So E equatorial magnitude will be how much? 1 by 4 pi epsilon naught q into 2a. Q into 2a will be the dipole moment P divided by r square plus a square power 3 by 2. Is that clear? So this is the magnitude of the electric field at the equatorial point. And what will be the direction? We know that in class 11 we had discussed about the parallelogram law of vector addition. So if we want to find the resultant of these two vectors, then we have to draw the parallelogram, and this common diagonal will represent the E equatorial. The common diagonal will represent the E equatorial vector or resultant of these two electric fields. And you can see that E equatorial is directed opposite to the dipole moment, because dipole moment is directed from negative to the positive charge, means towards right, but E equatorial is opposite to the dipole moment. So in vector form you can write E equatorial vector equal to 1 by 4 pi epsilon naught P by r square plus a square power 3 by 2 minus p cap. E axial, the electric field at the axial point is along the dipole moment, but the equatorial electric field is opposite to the dipole moment. Again, we will discuss about a special case, means for a short dipole. For a short dipole, r square is much larger than a square. So r square plus a square is approximately equal to r square, because we are adding a very small quantity to a very large quantity. So the result will be approximately equal to the large quantity. So in this expression, E equatorial will be how much? 1 by 4 pi epsilon naught p divided by, in place of r square plus a square, you can write only r square. So we have r square and the power is 3 by 2. The power is 3 by 2 and it is directed opposite to the dipole moment. So E equatorial will be how much? 1 by 4 pi epsilon naught p by r cube minus p cap. So this is the expression for the electric field due to a dipole at the equatorial point. So students, we have finished the derivation of electric fields at axial point and at the equatorial point, and we saw that E axial vector is equal to 1 by 4 pi epsilon naught 2p by r cube into p cap, and E equatorial vector is equal to 1 by 4 pi epsilon naught p by r cube minus p cap. So from this expression you can see that E axial is parallel to the dipole moment, but E equatorial is opposite to the dipole moment. And if you look at the magnitude of E axial and E equatorial, you can see that E axial is 2 times of E equatorial. Here we have 1 by 4 pi epsilon naught 2p by r cube, but here we have 1 by 4 pi epsilon naught p by r cube. So E axial is equal to 2 times of E equatorial, or E axial by E equatorial, this ratio will be 2:1. Is that clear? So in your exam you may get question to derive the electric field at the axial point or at the equatorial point. Now we will go to discuss about the third case. Third case means electric field due to a dipole at any arbitrary point, means the point is neither axial nor equatorial. The point is neither axial nor equatorial. For example, so the third case is at an arbitrary point. At an arbitrary point. So we have already derived E axial and equatorial, and we have already discussed that E axial is parallel to the dipole moment and E equatorial is opposite to the dipole moment. So the next case is at any arbitrary point. For example, we have a dipole consisting of 2 charges, minus q and plus q. O is the center of the dipole. Now I have a point P here. The distance of the point P from the center O is r. You can see that this point P is neither axial nor equatorial. So you cannot use the formula for E axial or for equatorial to find the electric field at this point. We have to use some other formula. So this is r vector, and the P vector is directed from negative to the positive charge. P vector is along negative to positive charge. And suppose the angle between P vector and R vector is theta. The angle between P vector and R vector is theta. The question is how to find the electric field intensity at this point P. So students, the dipole moment P vector makes an angle theta with R vector. Is that clear? So now if I resolve this P vector into its components, then I will get a component P cos theta along this R vector and a component P sin theta perpendicular to the R vector. Again I am repeating, if I resolve P vector into its rectangular components, I will get P cos theta along this R vector and P sin theta perpendicular to the R vector. So for P cos theta, for the component P cos theta, this point is an axial point, because assume that we have a dipole moment P cos theta along this line and the point P is also lying on that line, means this point is an axial point for the component P cos theta, but this point P is an equatorial point for the component P sin theta. Is that clear? Okay, so we have to find the electric field due to this dipole at point P and due to this dipole at the point P. Is that clear? So we know that electric field due to a dipole at the axial point is away, means is along the dipole moment, means along this direction, and electric field due to a dipole at the equatorial point is opposite to the dipole moment. So this point is axial point for P cos theta and equatorial point for P sin theta. So if you want to find the electric field due to this component P cos theta, then it will be parallel to P cos theta, parallel to the dipole moment P cos theta. And the electric field at the point P due to this component P sin theta will be opposite to P sin theta, because this point is equatorial point for P sin theta component. So E1 and this one is E2. E1 is the electric field due to P cos theta component and E2 is the electric field due to the P sin theta component. So what will be the value of E1? The value of E1 means the axial electric field. It will be 1 by 4 pi epsilon naught, or you can write K. You can write K here. K into, what is E axial? E axial equal to 1 by 4 pi epsilon naught or K into 2p by r cube. And what is E equatorial? K into p by r cube. So here E1 will be E axial, so it will be K into 2 into, here the dipole moment is P cos theta. For the axial field we have to take the P cos theta component. So E1 equal to K into 2p cos theta by r cube. And what is E2? E2 means the electric field at point P due to this component P sin theta, and the point P is equatorial point. So we have to use the second formula, E equatorial or E2 equal to K into P, means P sin theta divided by r cube. Is that clear? So you can see that E1 and E2, they are perpendicular to each other. E1 and E2 are perpendicular to each other. So the resultant electric field will be E1 square plus E2 square square root. we know that if we have two vectors A and B and they are perpendicular to each other, then the resultant is given by A square plus B square square root. So here I can write E1 square plus E2 square square root. What is E1 square? E1 square will be K square into 4P square cos square theta divided by R to the power 6 plus what is E2 square? E2 square will be K square P square sin square theta divided by R to the power 6 whole square root. Now you can take K square P square divided by R to the power 6 common. You will get 4 cos square theta plus sin square theta square root. And if you take this K square P square by R to the power 6 outside, you will get K P by R to the power 3, and this 4 cos square theta plus sin square theta can be written as 3 cos square theta plus cos square theta plus sin square theta. 4 cos square theta is 3 cos square theta plus cos square theta, and cos square theta plus sin square theta is 1. So E net or resultant electric field is found to be Kp by R to the power 3 into 3 cos square theta plus 1 square root. So this is the expression for electric field at any arbitrary point due to a dipole. And from this formula you can also calculate the value of E axial and equatorial. How? If the point P will lie on the axis, of the dipole. If the point P is somewhere here, then what will happen? This R vector will coincide with the axis. Means the angle theta will be 0 degree. The R vector will coincide with the axis. The angle theta will be 0 degree. So for axial point theta equal to 0. So what will be E axial? E axial will be Kp by R cube into square root of 3 cos square 0. Cos 0 is 1, so cos square 0 is also 1. So 3 into 1 is 3, and 3 plus 1 will be 4, and square root of 4 will be 2. So we will get K into 2P by R cube. K into 2P by R cube. And for equatorial point, what will be the value of theta? If the point P lies on the equatorial line somewhere here, R vector will be along this line, and theta will be how much? 90 degree. For equatorial point, theta is 90 degree. So cos square 90 is 0. So 3 into 0 is 0. 0 plus 1 is 1, and square root of 1 is 1. So E equatorial will be how much? Kp by R cube. This value will become 1. You get Kp by R cube. So students, these are the 3 derivations, but in your board exam point of view, you will get only the first 2 derivations: electric field at the axial point and electric field at the equatorial point. So this derivation, the third derivation, will not come in your exam, but you have to remember how to find the electric field at an arbitrary point. So with this we have finished all the things of this lecture. In the next class we will proceed further. Till then, bye bye and have a nice day.